everybody, and welcome to another video regarding Java. And today we will be talking about Chapter 6, and specifically Chapter 6 will cover classes, objects, and you should be familiar with a little bit about this topic because we covered it in PLD 101. However, since Java is an object-oriented language, Java uses objects and classes way more often than Python does. That's why it's very important for us to know how to work with those classes and objects and how to use them in our programming and in our programs. Here are the topics that we're going to cover today. So you should be familiar with some of these words right here. However, I will probably split this video in two parts. So the first four I will cover in this video, and then in the next video I will cover the other four topics. Now, let's dive in. We know that our objects, they exist in memory, and they exist for a very specific reason. So they should be performing some sort of task for us. And we know that objects have two general capabilities, and one of them is storing data. And you can see that by providing variables to your objects. And another word for that is fields. You may have heard fields in PLG 101, but as we all familiar with the word and term variables, those are simply fields. And the other thing is that objects can do for us, they can perform certain operations, and those operations are known as methods. Methods were covered in chapter 5, so if you have not watched chapter 5 video, I very strongly recommend that you go back and watch it, because some of these things that we're going to be talking about might be unfamiliar to you if you have not watched that video yet. Now, you are familiar with a couple of objects already, and I introduced you to a couple of them. First of all, the scanner objects in Java. Those are used for reading input from the user or reading input from a file. Then we have the random objects. They will generate random numbers for us. And the print writer objects. Print writer is strictly for writing data to certain files. However, there are some other objects that you might have seen, such as a file object for opening or creating an object of a file, and a string. Remember that string is not a data type in Java. String is actually an object. So yeah, not the first time that we see objects and classes. So whenever your program needs particular services of a certain object, then it's just gonna create that object in memory of your computer, and then it's just gonna call either that object's methods or use that object's fields, or as I said, variables as necessary. Now, a little reminder about classes. So classes is the blueprint for our objects. So basically it's just a piece of code that's gonna describe what your object should be doing and what your objects need to have, such as the object's fields and the object's methods. I provided you with an analogy in our last class in PLD 101 with a class being the blueprint for a house and the object being an actual built house. That's how I like to think about it. Now, another term that you have to be familiar with is an instance of a class. It's just another name to call an object. So if you see somewhere in your book or in your assignments an instance of the class, it just refers to an object of that class. And when your program is running, you can create as many objects as you need. So if you have multiple classes, you can create multiple objects of any different specific types, as many as your heart desires. So let's look at a couple of examples. So we have our scanner class right here, scanner, then a variable called keyboard. And what we're doing with the right side of our assignment statement, we are creating a scanner object in memory. And this is the syntax for creating a certain scanner object. As you can see here, we need the keyword new, then the name of the class, in this case it's scanner, and then we are providing whatever parameters and whatever arguments this scanner class takes. In this example, it's system.in, which means that we want to take our input from the keyboard. And let's look at the next one. We have the random, and this is the way to declare an object from a random class. Again, the keyword new and random with empty parentheses. This will create an object of a class called random. And this is the print writer that you have also seen before. And this assignment statement right here is just going to create a new object of the print writer class, a new instance of the print writer class that's going to open a file called numbers.txt. So far, what we've worked with and the objects and classes that we have worked with, they were provided by the Java API, which just means that they were already built in Java and we just had to call them. But today, we're gonna learn how to start writing our own class, step by step, with instructions, and let's dive in. So when we're designing a class, we have to think what our objects will need to have. So for example, let's think that we will be creating a class called rectangle, and that class is gonna have a rectangle object. So let's think, what do rectangles have? Which kind of variables our rectangle will need to have? First of all, it's gonna be length, obviously, and width. So only two variables that our object needs to have by default are length and width. Then after that, the second step would be to think which methods our class needs to have. So in this case, remember, let's take a couple of steps back. Remember when we were talking about setters and getters, because we do not want these variables to be easily accessible by anything that's outside of the class. So these variables are going to be private. However, we have to be able to change them somehow, right? And we will do that with methods. So we will have a method to set the length of our rectangle's length. Then we will have a method called setWidth that's just gonna do what it says. It's gonna set the object's width. Then we have getLength that's gonna retrieve the length of our rectangle, getWidth that's gonna retrieve the width of our rectangle, and then we can add another method that is just gonna calculate the area of our rectangle, which is gonna be called getArea, and what it's gonna do is just gonna be length multiplied by its width, and it's just gonna return just that number. Alright, another throwback to PLD 101, UML diagram, which stands for Unified Modeling Language. It just provides a standard diagram for graphically displaying any of your object-oriented system that you are going to create. And let's recall that the first box is where our class name will go. Then the second one is going to be all of the fields or variables that our object has, and then on the third one is going to be all of the methods that belong to this certain class. So for our rectangle class, this is what it will look like. The name, rectangle, right here at the very top. Then we will have two fields because we only have two variables, right? Length and width, they're right here. And then at the bottom, we have all of the methods that we want this class to have. Now let's start with the actual coding and how it will look like when we actually write the code for all of the information that we just provided to our class. So in this case, here's the definition of our class: public class rectangle, the name. Then the curly braces, because everything that's in between the curly braces just means that it belongs to this class. And here are our fields or variables. In this case, private, and we want it to be a double, which double just means it's a decimal, double length, and private double width. And you might be wondering why they should be private, because we have two different access specifiers, right? We have public or private, but we want our variables to be private because we don't want anything else to easily access those variables and change them, because these are very important. If our program provides a way for other parts of the program to access these variables, then they're not protected. You know what I mean? They're not protected, so it's just bad programming practice. So you just have to remember that all of your fields need to be private and all of your methods should be public. Now, here is the definition, a header for our setLength method. And if you watched the previous video, you should have noticed that there was another word right here, static. But static does not appear whenever we create methods for objects, because they are working on specific objects inside of the class. So we can just omit static as a whole. So all you need to set your setLength method, to create it, you need your access specifier. In this case it's public. Then whatever the return type is, in this case it's void, because we are setting the length variable to a certain value. We're not returning anything, so it's void. Then the name of your method, and then whatever parameter your method should take. In this case, we're creating a parameter called len that stands for length, and it's the data type is a double. Now, this is the Javadoc documentation right here. So it briefly explains what this method does. So the setLength method stores a value in the length field. Now we are specifying that we have a parameter called len, and that parameter is just gonna be the value to store in our variable length of our object. So again, this is the header that we just talked about. Then we have the curly braces, as every other method and class does. And then we are just setting the length variable to whatever parameter, whatever value was sent here. So this is the assignment, length equals len. This method will provide you with a way to set your actual variable to a certain value without interfering with that variable directly. So now let's create our own rectangle object. This would be the way how you would declare your rectangle object. In this case, you have to specify the class, in this case is rectangle, then the name that you want your object to have, in this case it's box, then the equal sign, then the keyword new, and then the name of your class again. So in this case it's rectangle, then parentheses, and a semicolon at the end. So right now, our box variable is going to hold the address that is provided when we create our rectangle object. And this address will take us to the fields variables that our object has. And in this case, the length is 0 and the width is 0, because we have not assigned those variables to any of the values. But let's look how we can change that. So to use your setLength method that we just created right here, all you have to do is use the variable that you just created right here. In this case is box. Then you would put a period and provide the name of the method as well as any arguments that you want to pass. In this case, we want to set our length to 10, and this is the way we would do it: box.setLength 10 in parentheses and close it with a semicolon. And now after we run this line of code, our lengths will be changed to 10, from 0 right here to 10. Now the getLength method is similar way. Instead of the parameter, because we do not have any parameters right here, you can see that our parentheses are empty. However, we have a return value. And in this case, in our comments, we will provide that we have a return value. And in our method header, we will change void to the data type that we want to return. In this case, it's a double. And then we're just going to specify which variable we want to return. In this case, it's length. Now, this is how your getArea method would work. Again, it's very similar to our getLength method right here. The only difference is that we are returning, instead of just one variable, we're returning a product of length, time, width. And we are specifying it right here. Our return value is the product of length, time, width. Now let's recall the concept of data hiding that I just described to you. That is why our variables need to be private in our class. However, to retrieve the data of those fields, they're called accessors, or sometimes you will also hear getters. That's the way I learned it. They're called getters. And then we also have setters, or also the word is mutators, and those just modified the data of your said fields. Now, each field or each variable that you as a programmer want to be view, they need a getter, and each variable that you want to change or modify, they need a setter. Yeah, as you can see here on this slide, the names for these methods are getters and setters. And for me personally, it was easier to remember this because of these little words in front of each method: set, get, get. So you can easily know that these are getters and they will get the value for you, and these are setters, they will set the value for you. And here are all of the methods that we have for our rectangle class. So you might be thinking why we want to use data hiding, and that's just because the more you're going to work with objects, the larger your systems are going to be. And in this case, we are trying to become software engineers, software developers, and whenever you will be working in your coding environment, you will have very large software systems, and that is why we need to have data hiding. It just helps, exactly what it says here, it helps enforce the integrity of your object's internal data. It just makes sure that nothing can access your object's fields if it shouldn't be accessing those fields. Alright, another concept that we're going to be talking about is called stale data. And stale data is just something some sort of data that requires calculations and that is dependable on various different factors. And in this case, we could have potentially stale data when we're calculating the area of a rectangle. But in our case, right here, we are not storing this calculation anywhere, right? We could have stored it in a variable called area. However, that would give us a potential to become a stale variable, and we do not want that. Now you can see here that instead of creating a variable called area, we're just calculating length and width dynamically, and that will prevent the stale data, and that will prevent our area of becoming stale or old. So whenever you will make any changes to the length or width of a rectangle object, it will dynamically recalculate your get area, and your area will never be old. So now let's look a little bit closer to the UML diagrams. So your UML diagrams, they are very language independent. So that just means that no matter what language you're going to be using, your UML diagrams will look the same. And in this case, we will also add a little new thing, access modifiers, and they are very easy to show. So minus stands for private and plus stands for public. Sometimes you will also see a hashtag sign, which just stands for protected, and that's just another access modifier that we're going to cover in the future. But just if you see this somewhere in the book, just know that it means protected and don't be alarmed by it. Now our variable type for each variable that your class has will be denoted with a colon, and then after that colon, the data type of whatever variable you have. Now the same thing goes for the method return types. Again, you put a colon and then whatever you are returning. And your parameters are shown inside of your parentheses. In this case, we have a parameter double, that's the name with a name W. Now you might be thinking, why would we create a UML diagram, right? Well, because you can convert that diagram into actual code without lifting a finger, basically, without writing a line of code. And in this case, if you create your UML diagram the right way, the program that's gonna create the Java class file for you is gonna know that the first one is gonna be your class name, which is gonna be put in the class header. Then the second one is gonna be your variables or fields, which they're gonna be appearing right here. And then the third one is gonna be your methods, which are also gonna be put after your fields. And look at this one. This would be our UML diagram for our rectangle class. So with lengths and all of our methods, with all of the specified return types, and the data type for our variables. This would be the code that would be created from your UML diagram. And as you can see, everything is created for you. The only thing that you will have to know and do is just fill in your methods. That's pretty much it. So once your class structure is tested and when you can see that everything is working the right way, the only thing that will be left to do is to just fill in your method bodies and then test your class again. So the layout of your source code, it just means this, the layout of your source code can be different based on the company that you're working for or any other educational facilities that you are studying at, but we are going to be using the common layout. In this case, the fields are going to be first and the methods are going to be second. And then all of your setters and getters are going to be grouped together. Now let's go back when I told you that our methods do not need the word static, and this is the explanation of why we are not using the word static. Well, because all of these fields and methods that are created on the first go are called instance fields and instance methods. Every single object that you create from said class is going to have their own copy of instance fields and their own copy of instance methods that they have access to. That is why if we are doing the instance methods, we do not need the special keyword static. Now let's look what we might use our class for. So in this case, we have three objects. One is kitchen, one is bedroom, and one is den. And you know that each one of these objects that we have created will have their own copy of the instance fields. So they can have different dimensions. And in this case, we can just set up our dimensions to very different values, right? So for the kitchen, the length can be 10 and width 14. For bedroom, the length can be 15 and width 12. And for den, the length can be 20 and width can be 30, which these are all very different. These are all very different rooms, but essentially they all come from the same class called rectangle. And that's the point of making your classes. Alright, so I think that was enough for the first video, first part of chapter 6. I will cover the second part in the second video. And just as per usual, let me know if there are any questions, if there's something that you're not understanding or if you're struggling with, just send me an email and we can work it out. See you in the next video. Bye.